Welcome to Free Python course tutorials. In this video, I will talk about the basics of connecting and programming your light emitting diode using Micropython and Raspberry Pi Pico. Now let's take a basic look at the LED. First, the LED stands for light emitting diode. The LED produces light when current is passed through them. The LED is a polarized device. You cannot reverse the terminals of the LED, meaning it has a positive side and a negative side. Current must pass from the anode to the cathode for the LED to light up. Now, let's look at the basic parts of the LED. So the LED, like I said, is a polarized device. It has the positive side, known as the anode, and the negative side, which is known as the cathode. Now you can visually identify which is the cathode pin and which is the anode pin. For the cathode pin, it has a larger plate, as you can see. The side of the casing of the LED has a flat edge on the cathode side, and also the pins are usually the shorter leg. And for the anode, the pin is the longer leg, and it has a round edge on the casing, and also the plate is a smaller one. The basic symbol for the LED is this. You have the anode, which is usually the triangular side, and the cathode, where you have this thin line. There are different types of and sizes of LED. So for the pinhole types, we have the 3mm, 5mm, 20mm, and even larger sizes. And also for the surface mount, we have the different sizes and configurations.
There are two different ways you can connect your LED to your microcontroller. One is the active high, and the second is the active low. In the active high, your microcontroller GPIO pin serves as the source. In other words, it sends current through your LED and down to the ground. Whereas in the active low configuration, your microcontroller serves as a sink. In other words, current is supplied from your positive voltage source. The current goes through the LED and is sunk in to the microcontroller. Now the question is this: which is the best configuration, active high or active low? Now you can use any of them, but however, I recommend active low. So what is happening in the active low is this: your microcontroller is not supplying current to your LED, so it's just acting as a sink. So in this case, you are likely to overdrive your microcontroller. Now let's look at this graph. So most manufacturers of LEDs will provide you with a data sheet. In the data sheet, you can see the fault voltage and fault current characteristic graph. So from this graph, once your voltage to your LED is less than 1.7, your LED will not light up because no current is flowing through your LED. So once your voltage exceeds 1.7 volts, your current begins to flow, and in that case, you begin to see your LED light up. Now, the normal voltage is usually about 2.0, where your LED consumes about 20 milliamps. Any voltage that exceeds that drives your current into a position that destroys your LED. So you don't want to supply your LED with a 9 volts. It's going to burn your LED. So to do that, you need to limit, when you're connecting your LED to your microcontroller, you must add a resistor. Usually, I recommend 220 ohms to 1 kilo ohms resistor. So note, the higher the value of your resistor, the lower the brightness of your LED. All right, so first we're going to design our circuit as active high LED configuration. So to do that, I need you to go to your Wokwi online simulator. If you haven't register, then sign in to your account. So select my projects under new projects. Go to new project, yes. Select Micropython or Raspberry Pi Pico. So come here, delete this. So first we're going to design our ActiveEye configuration. So select your LED and also select your resistor. Okay. So if you notice on your LED, there's LED A, means anode. So the anode is connected to the GPIO pin, so connecting to GP15, and the cathode is connected to your resistor. Okay, so the resistor is connected to ground. All right, so this is your active I configuration. Now we're going to write our Python code. So let's put a comment, active I. So first you need to import your pin module from your machine library. Then we're going to configure our LED. So we'll give it a variable name. It could be anything. LED is equal to pin. So in this case, we're going to select pin 15, and we're going to configure the pin as output. Okay. Next is while true, while your Raspberry Pi Pico is on, we want our LED to be on. .on. Okay, so simple. So let's run our simulator and see. Okay, so our LED is working. So currently this is an active I configuration. Okay, now so we're going to design the circuit for the active low LED configuration. So basically we need to select our components, so LED and a resistor. So what we are doing in this case is this: we are sending current from our Pico, 3.3 volts current. Sorry, from our Pico from 3.3 volts pin out. Then to the resistor, from the resistor to the anode. Then from the cathode to our GP15. Again, you can use any GPIO of your choice. All right. So I haven't done that. For the code part, so the same thing applies to the active low, similar to the active I. So import your pin from your machine module library. Import time if you want to add some delays. So we're still using our pin 15 and still pin out. Note it's still a pin out in this case. But what we are doing differently is instead of supplying a high voltage to our GP15, we are supplying a 0 volt. So what happens is this: if a 3 volts is supplied from your Raspberry Pi Pico, and this is a 0 volt, because of the difference in voltage, there will be a voltage drop, and as a result, the current will flow. But if this is high, to be 3.3 volts, because there is no voltage drop, then there's no way the current will flow. So let's run this and let's see what happens. All right, so you can see this is active low. Our LED is on. Okay, now, so we're going to toggle the LED using the active low configuration. So to do that, we still maintain the same low active low circuit. And also we import our pin module from the machine library, then also import time. And in this case, I'm going to modify the code so that it toggles 10 times, okay? So to do that, I'm going to create a finite loop. So for I, range, let's see, 10, it's going to toggle 10 times, right? Sorry. Okay, so I'll say pin, sorry, LED dot on. So it's going to go off in this case. Then sleep, that is delay for 0.5 seconds. Then LED dot Oh. So I'm going to ask you to print the iteration values. So as it counts from 0 all through to 9, you should also print on the screen. All right, so having done that, I'm going to run this code. So let's see what happens. Okay, so you can see it's blinking or toggling. And once it exceeds 9, it goes to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that's basically how to toggle your LED. So I'm going to give you an assignment to do the following. Find out how you can toggle your LED using the toggle function in your MicroPython. Toggle the LED 10 times. Also, create an infinite loop to toggle the LED. Then find out how you can adjust the brightness of your LED using the pulse width modulation in MicroPython.